Hi students and family members. In a previous video when we were exploring multi-digit multiplication times a one-digit multiplier, we related it to place value and how you could take a multi-digit number, place it in expanded form, and then multiply it by the multiplier. Such is the case with all multi-digit multiplication problems. Today I'm going to take you through a couple of examples that will hopefully show you how to use place value expanded form to multiply and then add a multi-digit number times a one-digit number, but then also how to use your knowledge of carrying numbers to use this standard algorithm to get the correct answer as well. So you can see I've expanded the numbers already for us. 203 is equal to 200 plus 0 plus 3. When I multiply each place value by the multiplier, I can then add them to get my final answer. Let's start with the ones. 9 groups of 3 is 27. 0 groups of 9, 0. And 200 groups of 9, or 9 groups of 200, is 1,800, or 1,800. Don't get scared off by these bigger numbers. Keep in mind I could cross these zeros out, do 9 times 2 and get 18, and drop the zeros directly into my answer. Now all you have to do is add them up. And if you like me, and you like organization, you're going to line them up vertically. That way it's going to be easier for you to add the ones, 7 plus 0, the tens, 2 plus 0, the hundreds, 8 plus 0, and the thousands, getting me a final answer of 1,827. You can also use the standard algorithm. Multiply the ones and carry anything that goes into the tens. So when I do 9 groups of 3, I get 27, or a 2 in the tens and a 7 in the ones. 2 tens, 7 ones. Anything times 0 is 0, but there's still this 2 up here, and anything that I carried needs to be added back in. So that will put a 2 in the tens. And finally, I can multiply my hundreds. 9 times 2 is 18, which leaves me with the final answer of 1,827. Let's try this one over here. I've expanded the number to 400 plus 60 plus 2, and my multiplier is 3. 3 groups of 2 is 6. 3 groups of 60, well, 3 times 6 is 18. Add my 0. And 3 groups of 400 is 1,200. Then just add them all together. Make everything matchy-matchy. 1,200 plus 80 plus 6. 6 is what's left in my ones category. 8 and 0 is what's left in my tens. My 100 is 2 plus 1. And my ones and my thousands, 1,386. Standard algorithm, 3 groups of 2 is 6. Nothing gets carried. Then move over to my hundreds. 3 groups of 6 is 18, or 100, and 8 tens. And then 3 groups of 4 is 12, plus 1 more, which is above here. Don't forget about that. That's important. 13, or 1,386. I think many, if not most, or all of the students are going to latch on to the standard algorithm, but feel free to use this as an organization tool or a checking tool throughout. Let's try 2 more. 221 expanded is 200 plus 20 plus 1. My multiplier is 5. 5 groups of 1, or 1 group of 5 is 5. 5 groups of 20, 5 times 2 is 10. Add a 0 because there is a 0 in 20. That's 100. And then 5 groups of 200, again, 5 times 2 is 10, but there are 2 more zeros in that 100, so it's 1,000. And add all of these together. 1,000 plus 100 plus 5 is going to give me 1,105. Standard algorithm gets me the same exact answer. 5 times 1 is 5 ones. 5 groups of 20 is going to be 1 in my hundreds, 0 in my tens. 5 groups of 200, 5 times 2 is 10, plus 1 more is 11. Carry that 1 into the thousands. You get 1,105. Expanded form for 724 is 700 plus 20 plus 4. My multiplier is 6. 6 groups of 4 is 24. 6 groups of 20, 120, because 6 times 2 is 12. Add my 0 back in. 6 groups of 7 is 42. Add your zeros. So 4,200 plus 120 plus 24 will leave me with a 4 in the ones, 4 in the tens, 3 in the hundreds, and 4 in the thousands. Sorry for this weird writing here. 4,344. Check it out with the standard type of mathematical algorithm. 6 groups of 4, 6, 12, 18, 24, which means there's a 2 in the tens and a 4 in the ones. 6 groups of 20, or 6 times 2 is 12, plus 2 more is 14. Because it was 20, I carry 1 over into my hundreds. This 4, which is worth 40, is in my tens. Then 6 groups of 700, or 7 times 6, is 42, plus 1 more is 43. Because that 4 then goes over into the thousands, and I've added my 1 back in, is 4,344. Let's make it a little bit more difficult and add a 4th digit. Check it out. Now I have a 4-digit multi-digit multiplication problem by a 1-digit multiplier. It's the same exact process. Expanded form tells me that 4,102 is equal to 4,000 plus 100 plus 0 plus 2. My multiplier is 4, and now I'm just doing groups of each number in each place value and then adding them up. 4 groups of 2 is 8. 4 groups of nothing, nothing. 4 groups of 100, don't forget your plus lines, plus markers, is 400. And 4 groups of 4,000, 16,000. Now just add them together. I'm going to take everything, make them matchy-matchy. Vertical, I don't even need to put the 0 there. And then when I add them together, I end up with an 8 in my ones, nothing in my tens, 4 in my hundreds, and then, oops, that should be 16,408. Let's check my answer. 4 groups of 2, 8. No groups of 4 or 4 groups of nothing is 0. 4 groups of 100 is 400. That's why the 4 goes in the hundreds. Then 4 groups of 4, 16. And it's 4,000, so 1,000 goes into the thousands. And I'm sorry, 10,000s, and 6 goes into the thousands. So we're left with 16,408. That's correct. It's all checking out. I can do it this way or that way. Standard algorithm carrying numbers would work here. Expanded form, 9,000 plus 0 plus 30 plus 7. What's nice about these is you've got a 0 number. So we start by multiplying the ones. By our multiplier 3. 7 groups of 3, 21, plus 3 groups of 30, which is 90. There's nothing in my hundreds. Anything times 0 is 0. And then 9,000 groups of 3, or 3 groups of 9,000. 9 times 3 is 27. And add back in my 3 zeros. Now I just add back my 90 and my 21. And I get my final answer. 1 plus 0 plus 0 is 1. 9 plus 2 is 11. Bring down my 1 in my hundreds. And then a 7 and a 2. 27,111. 3 groups of 7 is 21, or a 2 in the tens. 1 in the ones. 3 groups of 3 is 9 plus 2 more. It's 11. 3 groups of nothing is nothing, but there is that 1 up there, so you have to add that in. It gives me 111. And then 3 groups of 9, 9 times 3 is 27. 27,111. Let's do one more together. Expanded form for 5,955 is 5,000 plus 900 plus 50 plus 5. Our multiplier is 8. 8 groups of 5 is 40. 8 groups of 5 is 40 again, but there is the 0 there, so 8 groups of 50 is 400. These eventually will be added together. 8 groups of 9 is 72, but don't forget about those zeros, so it's 7,200. And then 8 groups of 5, but 5,000 are going to be 40 again, but 3 more zeros, which is going to be 40,000. Now, because this is all scrunched in, it's difficult to see, I'm going to rewrite my addition problem over here, and I encourage all students to do this. 4,000 plus 7,200 plus 400 plus 40. When I add my 1s, I'm left with 0. When I add my 10s, I have 4. 4 plus 2 is 6. Here's my 7. And 4. 47,640. I've already started the standard algorithm over here. 8 groups of 5 is 40. 4 groups of 10 and nothing in the ones. 8 groups of 50 plus 4 is going to be 44. So my 4 goes into the hundreds and my 4 down here. Then 8 groups of 9 is going to be 72, 73, 74, 75, 76. Carry my 7. Bring down my 6. 8 groups of 5 is 40 again. 41, 42, 43, 44, 45, 46, 47. Carry your 4. Bring down your 7 and then drop down that 4. 47,640. The standard algorithm is certainly going to get it there quicker, but if you'd like to use place value, remember, expand the number first, then add them together as well. Hope this video helps.